Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome back in lecture 01 example 1. I designated this lecture by E1 E2. Okay, so this is first example, that's why I designated this lecture by E1. Right, this example is basically related to the review question, and in this example basically we see how to review, how to analyze a given rectangular beam section. As in part 11 we will discuss the difference between the review problems and the design problems. In this lecture you will see how to review rectangular section, right? So before start this example, you people must know how to start, what is the path which we have to adopt, right? This is very important. First of all, we must know what is the way, what will be the path, how to analyze a section or any given section, right? So the path is this one. The first step is that we will determine the A value, right? We need to find out the A value because we already know area of steel, because area of steel is given to us right here. You can see this one, right? We know about the width of the section, right? We know about the depth of the section. So that's why we can find A is by using the equation A is Fy divided by 0.85 Fc prime into B. So by using this equation we will find out the value of A. Then we need, in step 2, we need the value of C, right? So C can be determined by using the A divided by beta 1, right? You must make sure that what will be the value of beta 1. If Fc prime is, let's say our Fc prime is 4000 psi, so we know that then the beta 1 value will be 0.85, right? But if Fc prime less than or equal to 4000 psi, then the value will be 0.85, right? If in our case, as in this example, we see Fc prime is 5000 psi. So in this case we have to calculate beta 1 value by using the above equation, right? You see here I have already write down here 0.85 minus 0.05 into Fc prime minus 4000 divided by 1000, right? So this equation will be used right in this example and we will calculate the value of beta 1. After this, once you got this, we will find, remember, before starting this example, before starting a review problem, we will use our two criterias. What was those criterias? I have already mentioned those criterias, that we have to assume that epsilon u will be equals to 0.003. This is our assumption, right? And the next criteria is this, that Fs, that steel must be yielding. We will use these two criteria and we will satisfy in later that whether these criteria is fulfilled or not, right? If this is fulfilled, so we will proceed. If it's not fulfilled, we have to revise our design. Now after this, once we calculate the value of beta 1, right? By calculating the value of beta 1, we will checking this criteria. This criteria is to be checked by calculating in step 3 the value of epsilon s by using the proportionality d minus c divided by c into epsilon u, right? We will calculate the value of epsilon s. Then once we got the value of epsilon s, we will compare the epsilon value with the epsilon y. What will be the epsilon y? Epsilon y will be calculated by using Fy divided by modulus of elasticity of steel. So by getting this value, we will compare these two, right? We will compare these two values. If epsilon s is greater than epsilon y, if epsilon s is greater than epsilon y, what does it mean? It means that our criteria fs equals to fy, right? This means the steel is yielding for this, because sometime when the steel is placed D, as I already discussed this in part 4, part 5 I think so, that D will be equals to dt. So in this case the epsilon s value will be equals to epsilon t, right? In this case, if the steel is placed in one layer. So this suggests that if the steel is not placed in two layer, right, in one layer, then remember epsilon s will not be equals to epsilon t, and we have to find out the value of dt, right? And I already explained this in part 6, 7 I think so, that how to calculate the dt, right? I will do some example over it, that how you can calculate the value of dt, right? So we must make sure, what does I mean here, that you have to find out the value of epsilon t. If it is equals to epsilon t, epsilon is equals to epsilon t, then it is okay. We will compare this value with two values, 0.005 and 0.002, right? If it is more than 0.005, then it suggests that our p value will be 0.9, right? If it is epsilon t is less than 0.002, then epsilon p value will be 0.65, right? And if it is in between these two values, right, it is greater than 0.002 but it is less than 0.005, then we have to calculate the p value, that is 83 point, this is equals to 83.3 plus 0.48 into epsilon t. Please check this equation, right? So this is the procedure. After adjusting the p value, we will finally find the mn value by using the equation as fy into d minus a over 2. So let's see how we will solve this equation, this example, by this approach. Here you can see the data. The data is already I have write down here. The noting that the FC prime value is 5000 psi and the Fy value is 50,000 psi. So this is important to understand, that we have to calculate first of all the value of beta 1, right? And from that equation, if you use that equation by just plugging the value of Fy equals to 5,000, you will get the value of beta 1 0.80, right? So this time you have to use beta 1 equals to 0.80. So after finding the value of beta 1, then we need to find out the value of A. Now by using the same equation of A is Fy divided by 0.85 Fc prime into B. As the S value is given, that is 5.08 square inches, it is already given to us. Fc prime is 5000 psi and Fy value is 50,000 psi and B value is 14 inches. We will calculate the A value, that is 4.27 inches. This one will be the value of A. Now what we need to find out the value of C. So the value of C will be A divided by beta 1. So from this, using the value of beta 1 0.8 and A value is 4.27 inches, we have the value of C, that is 5.37 inches. Now finding the value of C, we will calculate what? We will calculate the strain in the steel. So strain in the steel, epsilon s. Now epsilon is equals to d minus c divided by c into epsilon u. We know all the values. Epsilon u is 0.003. We know d, that is 21.5 inches. Just plug all the values and we got 0.0091. 0.0091. Now here you can see in this example that the steel is placed in one layer. This is very important. You must know this, that the steel is placed in one layer. So it suggests that in this case that our effective depth equals to dt, and it also suggests that epsilon is equals to epsilon t. This is important, right? This is important. Now as epsilon is, in this case epsilon is equals to epsilon t, because the steel is placed in one layer, and we will equate this with the epsilon y to make sure whether our assumption, that is fs equals to fy, we will using this assumption right here while calculating the value of a, because here we are considering fy equals to 50,000 psi. So that why we are using this assumption. Now here we have to check this assumption whether it is okay. So for this we will find out the epsilon y value. Epsilon y will be calculated by using the fy divided by 29,000, right, ksi. Here we will plug the value 50 and here we have the value of 29,000 ksi. So from this you people will got the value of 0.0017. 0.0017. So this is interesting that here we can see that the value of epsilon t, the value of epsilon t or epsilon is far away. You can say it is more than, it is far away the value of epsilon y, that is 0.0017. This means that our criteria, our assumption is okay, f is equals to fy, and the steel is yielding, right? This means steel is yielding. Now we have to compare this, because we have to choose the value of p right now, right? We need to find out the value of p. So as we see, the epsilon t value is 0.009, right? 0.0091. So this value is more than, it is more than, is far away from the ACI defined value, that is 0.005. If you remember the graph, I have already showed this in, I think so, in part 8 or 9. We know the graph, right? Let me draw the graph right here. That right, this is the graph. This is the strain value 0.002 and this is the strain value 0.005. The value of p, because here we have p value and here we have strain value epsilon t. So here the value is defined by 0.65 and here the value is 0.9, right? So this zone, remember this zone is a compression zone. This is a compression zone. This zone is basically is the transition zone, right? And this zone, this is the tension zone, right? So as we see that our epsilon t value is more than 0.005, so this suggests that our section is lies in the tension zone, or the section is a tension controlled section, right? So that why this suggests that the phi value, we can choose the p value is 0.9, right? So now we are able to find out the value of mn, right? Mn equals to as fy into d minus a over 2. Here you can got the value of mn, that is 410 kip feet, right? Make sure you have to multiply this 1 divided by 12 divided by 1000. If you are using s in inches, fy then will be 50,000, d will be 21.5 inches, and a value as calculated 4.27. Then divide that value by 12 to convert it into feet, and divide by 1000 to convert it into kips. This one will be the desired value, and if you are interested to find out the design capacity, then you need to multiply that value by mn. So you multiply 0.9 with 410, you will got your required value in kip feet. This ends up this example. See you in next lecture. Thank you for watching.